Good morning. Bit of a gloomy Friday here. I hope it's sunnier when you see this. And this is all about the atmosphere, so gloomy kind of fits in, right? It's about warming up a lot of it, but it also is about pollution. It's about all kinds of different things we've been talking about, like, right, habitat destruction, like cutting down forests, right, which disrupts food chains, right, which over exploits those trees in that forest. This one's not much about introduced species, right? But all of it's, linked to a threat to a decrease in biodiversity, which is bad for that big Jenga game we call the food chain. So this is scary, right? The state of West Virginia is not a small space, and that much every year. Tropical rainforest cut down, just the tropical kind. Okay, how does that affect this thing that we call global warming? All right, so here we go. So first of all, the concentration of carbon dioxide has been increasing. We'll see a graph in the next slide. Um, Carbon dioxide's released when you burn those fossil fuels. Now we're back to the carbon cycle, right? And so now we're talking about the carbon dioxide here that's part of the atmosphere getting used by photosynthesizers and becoming part of an organic molecule. And then organic molecules broken down by respiration by all living things to go back to carbon dioxide. And this cycle is what we talk about mostly in biology. But this also happens to some of those organic molecules. They do that process called fossilization and turn into these kind of fossils, which are therefore called fossil fuels, and they're basically unavailable because they're buried quite deep, and this process is very slow. But then we humans started to do this. We started to dig them up and burn them a lot faster than they fossilize. That's what makes these a non-renewable resource, right? Can more get made? Yes, but so slowly that in effect they're non-renewable. And this is where the concentration of carbon dioxide is increasing because when you burn these, just like when you exhale, this releases carbon dioxide. Okay, so here's a graph, right? This is carbon dioxide levels. This is since 1960, as you can see, up to just 2000. If we made this up to 2020, we'd keep going this way. Here's the temperature superimposed upon this. It's the average Earth temperature. These are things that you can measure. These are not debatable things. It's kind of like your weight. You can measure your weight. It is what it is. Now, what caused it to be what it is a lot of different factors. And so what has caused this is, lots of different factors, and it's hard to sometimes realize how much of this and how much of that affects it. Like how much of your weight is due to your exercise compared to your diet compared to whatever. Okay, so these are some pretty scary numbers. This is an increase of over 30% in roughly 60 years. So here's this thing called the greenhouse effect, because now we're back to warming. So this is the Earth, okay? But you could also pretend that this is your car, right? And so this is the atmosphere, which you can pretend is like your car's windows, because it's very similar. Your car's windows let the light in. Our atmosphere lets the light in, right? What's that radiant energy do when it hits your car's dashboard or the surface of the Earth? It jiggles molecules, and that causes them to release a different kind of radiation out called infrared radiation, also known as heat. But here's what your car's windows do with that heat, just like those kind of gases we call greenhouse gases do, and like the windows of a greenhouse, which is where this got its name, right? I would call this the hot car effect because you're much more familiar with that. The heat infrared radiation can't get out. All these other kind of wavelengths of radiation could get in, but the heat can't get out, not very easily, so it traps it, warms up. That's a good thing, because without this greenhouse effect, the Earth would be way too cold for any kind of life. But it's like Goldilocks and the Three Bears. Enough is enough, right? Too much is no good, too little is no good. So what has increased here is this layer of heat trapping gases therefore the temperature. Okay, so how does this affect the water cycle? Well, more heat means more evaporation, right? And that means more rain, more evaporation and more rain, more runoff, all kinds of dynamics of the water cycle are also tinkered with, so to speak, by this increase in carbon dioxide. So now, carbon dioxide is not the only gas that traps heat. In fact, there's several. We're going to bump into just two more, and one of them here is methane. Methane is CH4, right? It's also known as natural gas. If you have a gas stove, you're burning not methane but propane, a cousin of it. It's C2H6, and it's quite flammable. Well, methane is produced, you might remember, by some kinds of bacteria, mostly kinds that live in anaerobic conditions, like deep in the soil. That's what this is, deep in the soil. And they produce this gas, which then gets trapped if, especially, it's got frozen ground above it, like in Siberia. That's this little place here, and that's this place here. Unfortunately, the warming is causing this to thaw and causing this to be released much more than it normally would. And there is so much methane in all around, but in the especially in Siberia, that this, if you can read this, 25 times more powerful of a heat trapper than carbon dioxide. These are the two big players in the global warming thing. Um, One of them released by human activity to a great degree, the burning of fossil fuels, and the other one that's getting released because of the warming that's coming from the burning of fossil fuels and the upside of carbon dioxide. So, haha, got to have a haha every now and then, right? But see, it's a good thing that your party balloons are not filled up with methane, because that's what this cow is farting out. Why? Because inside of its guts, kind of like underground, is a nice anaerobic factory where those bacteria can eat the cow's part of the cow's lunch and produce methane. And if you filled your balloons up with methane, that would be bad. So, what is the result of this warming? Well, more severe weather of all kinds, not just hot, but also cold, more severe and more frequent severe weather. We're seeing that. This last week, we had a couple good tornado warnings. That's not, totally due to this, but it's increasing in frequency. And then this is the one that we talk about a lot, ice caps melting, which will cause sea level rise. The next slide is going to be Miami Beach when it goes up 2 degrees centigrade, which it's expected to do within the next 100 years, this century, in other words. And then what also happens when places get warmer is that organisms are going to start to move. In what respect? Well, if Pennsylvania used to be too cold, remember this story, for these beautiful insects called ash borers that kill ash trees that they make baseball bats from. If Pennsylvania used to be too cold for it 50 years ago, but now are not too cold for them, they have moved in and they have caused this. So here we have the idea that that's non-renewable resource, right, will also run out someday. So someday, whether we like it or not, we're going to stop burning fossil fuels because there just won't be any more. There might be a great amount, but there's not an infinitely great amount. There you go. That's Miami Beach. That's what it will look like. They are already, I have a sister that lives down there. They are already doing some engineering to deal with the sea level rise that they're already seeing right now. But you can imagine, you can engineer all you want. You're not going to stop water when it wants to go somewhere. It means you can't live here. You're going to have to live back here, or maybe up in the mountains, or whatever. So what? Well, I could argue, so what? Human beings have moved and lived in different places for all of history. Um, that is not a huge deal that we might have to live somewhere else or organisms might have to live somewhere else. That in itself won't be a total disaster to the biodiversity on Earth, to any kind of species, but this will. So carbon dioxide mixing with water creates a kind of an acid called carbonic acid. And we are seeing, this is a measurable thing, right? We are seeing the pH drop, right? More acid means lower pH in seas, right? And if the sea level rises, you can move somewhere else. But if the ocean pH drops, if the sea acidification increases, here's what happens. Acids are not good for metals. They break down lots of things, including metals, including the kind of metal calcium that, combined with some other things, the little creatures that make up a good bit of the near bottom of the food chain, primary consumers, make their little shells out of. And if they die a lot, now we have that Jenga game happening. And if a food chain collapses, you can't move to a different food chain. This is not like if this Publix closes down, you go to another Publix. Eventually, this is the biggest potential catastrophe with the carbon dioxide increase. The warming, to be quite honest, it's just going to change selection pressures. This is going to be a much bigger factor. So I had to cut this into two. I didn't think I could make it. That's a neat picture. I took that, I don't know, man, a while ago, speaking of sea level rising. So I got to go because I had to cut this off. Like I said, you know how the Roman Empire got cut in two with a pair of Caesars? That's solid gold.